Welcome, guys. So, right now, something is erasing the universe between every galaxy, every star. The space is expanding faster than light itself. Scientists call it dark energy, and it makes up the majority of everything that exists. So, we are living in a cosmic ocean where islands of matter are drifting apart, never to reunite. You will journey through voids so big they should not exist. So let's talk about that today, right? So if you are ready to see how terrifying this emptiness truly is, hit that subscribe button and like this video, right? So let's go, man. We descend into the void now. Ready? Let's go. So you look around you, everything you see, everything you touch, every person, your grandma, your dad, everyone exists because of matter, right? So your body, this planet, every star burning in the sky at night, same thing, right? So scientists have confirmed through many years of observation that all of that combined make up less than 1% of the universe. The rest is just empty. What? So imagine taking every galaxy we can observe, all the billion, whatever, all the stars and everything, every planet and even the chair that you're sitting on. Are you in bed? Okay, whatever. You will feel less than a trillionth of the space that exists. The average density of the universe is roughly 6 hydrogen atoms per cubic meter. Walk into an empty room and you are breathing in billions more particles than what fills the same volume in deep space. I'll do this a lot, so bear with me. So this emptiness is not just random, right? It's measurements from like satellites and Hubble, God bless that guy. They reveal that matter clusters in thin filaments and walls like a cosmic web, kind of. Between these structures, regions stretch so empty that they make the space between the stars look crowded. Astronomers call them voids, and they dominate everything, actually. Think of the universe like an ocean, yeah? Galaxies are not scattered evenly, like it's not evenly distributed. So they gather in tiny, tiny like groups floating on the surface, yeah? While big, big bubbles of nothing just sit there underneath, So you live inside one of those groups and you are surrounded by darkness, and it's a lot of darkness. So why is this important? Why are we talking about this today? Because this darkness this emptiness is growing every day, every second. Space itself is expanding, yes, pushing those bubbles of nothing wider. Are you with me? So it's just growing every day, driven by a force we don't know. We don't know what is causing all this. So they call it dark energy, and it fills these voids with something stranger than empty space. Bear with me. So scientists are measuring this distance supernovae. The plural of supernova is supernovae. So for those who don't know. So in 1998, there was this discovery that the expansion is speeding up, which is not supposed to be happening, guys. Gravity should slow everything down, right? Pulling matter back together, yeah? Instead, something in the void, in that void, is overpowering gravity itself. The emptier a region becomes, the stronger this force grows. You exist in a very tiny window where stars still shine and galaxies cluster close enough to see them, yeah. But the void is winning. It's like the Golden State Warriors when KD was there, you know. So with every passing moment, more space opens between these islands of matter, you know. So eventually, the darkness will separate everything so completely that entire galaxies will vanish beyond reach, swallowed by expanding nothingness. Yeah, that sounds right. So what lives in that void is still a mystery. What we know for certain is this: emptiness is not passive. It is active, very aggressive, you know, like those bulls we see in Mexico. They call them what, toros, or whatever they call them, yeah. But the true scale of this void is something you cannot imagine yet. The largest structure we can map are not clusters of galaxies. They are empty spaces between them. Wow. So in the year 2004, astronomers completed the Sloan Digital Sky Survey, SDSS, a project that mapped over 1 million galaxies across billions of light years, you know. And what they found, bro, you don't want to know. You don't want to know. So galaxies formed like these thin threads and sheets surrounding big, almost enormous vacuum. Some of these bubbles measured over 1 billion light years across. So to cross one of these voids, I don't want even to say the time, yeah? When it's a long time, you can't cross this void, yeah? It is big. So these are not small gaps between neighborhoods, like moving from your ghetto to Walmart, you know. They are separated by entire regions of the cosmos inside a typical nothingness or void. Yeah? You will find perhaps one galaxy per every 10 million cubic light years. Bro, today I need pull up your calculator because the numbers are crazy. Crazy. So the difference is staggering. Let me tell you, you could fit millions of galaxies inside a single void. Let that sink in. Yet most contain almost nothing. Nothing. Scientists are using supercomputers to run these simulations of cosmic evolution. And actually, they started with the conditions moments after the Big Bang, you know, and let gravity do its work over billions and billions of years. And the simulations, do you know what they provide? They produce like the same web-like pattern we usually see. So matter naturally occurs naturally collapses into dense filaments while voids expand between them. This is confirmed science, validated by multiple independent studies. Neil deGrasse, you can verify this. But here is where things start, doing shaggy. The voids are growing faster than the simulations predicted. What? It actively inflating them. They are being like pushing their walls outwards. At they are accelerating. This is crazy. Measurements from the Dark Energy Survey shows that voids expand roughly 10% faster than expected based on gravity alone. What does this mean for you? Every galaxy sitting on the edge of a void is being pulled in two directions. Gravity tries to keep it connected to nearby galaxies. Dark energy tries to drag it into isolation. Right now, gravity still wins in dense regions, But in the voids, whoa, dark energy is dominating completely. It's like the USA men's Olympic team, back to back, like I don't know how many years. So think about this. Standing at the edge of an expanding chasm, the ground beneath neighboring towns is moving away, slowly at first, then faster. And eventually, the gap becomes too wide for you to cross. So that is happening to our galaxy clusters across the universe right now. And the voids between them are becoming permanent barriers, dividing the cosmos into isolated kingdoms that never communicate again. The emptiness is not waiting in some distant future. It is here with us, surrounding us, bro. It's crazy. Growing every moment, and one void in particular reveals just how extreme this emptiness can become. So in 1981, before I was born, some astronomer called Robert Kastner discovered something that should not be existing. So while he was mapping these galaxies in the constellation of Bess, his team found a region containing almost nothing. Pardon. They searched the area repeatedly using increasingly powerful telescopes. These telescopes are a powerful one, yeah? So, in short, a sphere of darkness measuring like 330 million light years across, nearly empty, It's nearly empty. Anyway, I'll give so the Bose void is different. Let me put off this thing first, yeah. It's distracting me. All right, so where are we? Yeah, the guy in 1981, right? Yeah, so this guy named Robert has discovered something that he never knew he will see. So while he was mapping these galaxies in the Bess constellation, there's a constellation called Bess. So his team found a region that contains almost nothing, yeah? So they searched the area repeatedly using these telescopes. And the results remained the same every time. A sphere of like darkness measuring 330 million light years across. That is what, it's nearly empty. That's what he found. It was empty. So most cosmic voids contain sparse galaxies. Yeah, they are scattered throughout. It's like dotted, like an Appaloosa if you keep horses, you know. So the Bose void is different. In a region that should hold roughly like 10,000 galaxies, scientists found only, guess how many they found? 60. That is like 99 point some, actually 99% of vacancy. So if our galaxy existed like in the center of this void, we would see almost no neighboring galaxy anywhere in the night sky. So just darkness in every direction, front, right, left, center, nothing. So our astronomers call it the great nothing. That is the actual name. Some call it like the super void. The size alone violates what we thought was possible, okay? So according to standard cosmological models, structures this empty should be like very rare. It should not be something we should be seeing. So the universe has not existed long enough for gravity to evacuate in such a massive region completely, you know. So yet there we have this thing, yeah, confirmed by multiple surveys, many surveys, including data from the 2D. I don't know how to pronounce that. It's a survey. I will tell. I will give you. I'll put it. Yeah. So one theory suggests the void formed from an unusually low density region in the early universe, and as expansion continued, dark energy pushed matter away faster than gravity could pull it back. Listen very carefully. Over billions of years now, over time, the void inflated while galaxies fled to its edges, you know, because it's expanding. So some simulations show this is possible through statistics, you know. Another theory that is disturbing is that some scientists propose that voids that are this big could indicate variations in dark energy itself. If the force tearing space apart is stronger in certain regions, those areas would become empty faster. This would mean this universe is not like very uniform. Some neighborhoods they face faster destruction than others. For anyone living in a galaxy inside this void we are talking about, the night sky would appear almost, you know, crazy, alien. Instead of seeing thousands of distant galaxies through telescopes, they will observe perhaps a few dozen, like dim lights, you know. Their view of the universe will be like limited because the surrounding is very empty. So this void sits roughly like 700 million light years from Earth. We can observe it because light had time to cross that distance. But as the void continues expanding, eventually even that light will struggle. It can't reach us. We can't see it. So the darkness will grow more darker. So, and our measurements show the void is expanding at the same rate as the rest of the universe. But who is believing this? Its sheer emptiness makes it a preview of what awaits for everything, man. Every galaxy cluster will eventually become an island in a void this big, you know. It's not an anomaly though. It is a warning. And the force creating these voids is something we are only understanding now. Something invisible. It fills the universe and wants to rip it to pieces. In 1998, two teams of astronomers studied distant supernovas to measure cosmic expansion. They expected to find that gravity was showing everything. The gravity was like it was slowing everything down. Instead, their data showed the opposite. Expansion is accelerating. Galaxies are going farther away and are moving faster than those nearby. So this discovery earned the Nobel Prize in Physics, but it revealed a force we never knew actually existed. So scientists named it dark energy. The name is it is like that because we have no idea what it is. We don't know. We just know what it does. It pushes space apart. And I think of the universe as a balloon being inflated. So galaxies are dots drawn on the surface of that balloon. So as you blow this air into the balloon, every dot is like moving far away from each other, from each other dot, you know. So now imagine the balloon is inflating faster every second. So that acceleration comes from dark energy. So the blower is that. Okay, you get the point. So 70% of the total mass and energy in existence, we can't see it, we can't touch or directly detect. Normally, we only see its effects. Here is what confirmed observations tell us. Dark energy behaves like a property of space itself. Create more space through expansion and you create more dark energy. What does this mean? This means the force grows stronger over time. So early in the universe, when everything was compressed together, you know, dark energy was weak. Gravity was the dominant force. But as space expanded and matter spread apart, dark energy gained control. Measurements from the Wilkinson microwave anisotropy probe mapped the cosmic microwave background light, the background light from the universe, like it was only like 380,000 years old. So those measurements combined with the supernova data gives us the current expansion rate. So space is stretching at roughly 46 meters per second. So for every 3 million light years of distance. So this rate increases the farther away you look. What does this mean? You know, my task. So pick two galaxies and separated by like 100 million light years. Every second, the space between them grows by like 100 and like 1.5 kilometers maybe. They are not moving through space. Space itself is expanding, carrying them apart. Nothing they do can stop it. You know, and let me tell you the scary part is how smoothly this happens. it is so smooth that you cannot feel it. The dark energy, you can't feel it, because gravity is holding these atoms and planets and every galaxy clusters together. But if when you cross into now the voids between the clusters, where gravity is very weak and dark energy is the more dominant force, those regions are expanding faster than anything inside them can resist. So some physicists theorize that dark energy might actually change strength over time. If it grows more powerful, expansion could accelerate faster than they predict. And if it weakens, then the universe might slow down. Who knows? But the current evidence that we have, they say it remains constant, which means the acceleration we see today will continue forever. But who knows? So dark energy is not destroying matter. It's not destroying matter directly. It is destroying the proximity. Proximity. Every structure in the universe will eventually become like an island, surrounded by this unreachable darkness, and the speed at which this isolation is spreading is actually increasing. So stand still and measure the speed of a distant galaxy, wait maybe some more years and measure again. It will be moving faster this time, So this is not speculation, but it is actually confirmed by these observations stretching way back, The Hubble telescope tracked galaxies across history, measuring their speed, velocities at different distances. And the further away a galaxy is, the faster it is receding. Anyway, but more importantly, galaxies are at the same, when they are at the same distance, they are moving faster. I don't know. I don't get it. So galaxy. Okay, let's talk about those farther away. They are still moving even faster. Eventually, you reach a distance where expansion carries objects away faster than light itself can travel. And this is what we call the cosmic event horizon. So once a galaxy crosses the horizon, its light can never reach us, ever. The space between us expands faster than photons can cross, So from our perspective, the galaxy effectively vanishes. It still exists, of course, but we are permanently cut off from it. Any civilization living there could shine a very bright torch or a laser or something, but we will never see it. So currently, the event horizon sits roughly like 16 billion light years away, But it is moving closer as this dark energy continues to accelerate expansion. That boundary creeps towards us. Yeah, it's crazy, guys. I cannot believe that I'm actually telling you this. Anyway, I am still studying this thing, and I will update. I will post another video after this to continue on this. This is a very long topic, and I will do like a part 2, maybe a part 3 of this. Okay, so yeah, at least now your head can hurt like mine is right now. Anyway, I love you guys. No, I don't love you guys. Thank you for listening, and yeah, see you on the next one.